Hello everyone, my name is Daniel Felipe Bautista Suarez and today I'm with Ana Maria Lanchero Pulido and we are going to talk about the study on the application of advanced power electronics in a smart grid.
Okay, the first part is the introduction about this article. Is 5 demands of a smart grid for advanced powers electronic of technology. The first demand is to strengthen the optimization and ensuring the safety of the power grid. Okay, in this case, advanced power electronic device is an important means of the system control. The second demand is the promote the effective utilization of renewable energy. In this case, the large scale decentralized renewable energy that's main disadvantage such as the intermittent and uncertain. The third demand is the improve the power grid power quality and power market. The fourth demand is safeguard power electronic device reliability. This means that the disadvantage of this exit simulation technology also limit the development of power electronic technology. Therefore, power electronic must establish a unified simulation platform to ensure the reliability of the power electronic device. And the last one demand is the promote the energy conservation and emission reduction technology research.
Now, I'm going to talk about a little about the research and development trend of advanced power electric technology. The aim of the DC transmission technology is to realize the core device of a DC network. What does this mean? The use of a big generalized DC network to provide energy to the different parts of the world. The DC network is pretty expensive in comparison to the AC network, but it is a little more stable in its terms of power and the continuity of the flow of current. So what will this paper show us about this problem? Well, it would show us that the key to this research is to solve key problems of intelligent power distribution network and to implement custom power product certification gate and constraint mechanisms. What is this? To the key to making this work effectively is to implement custom parts, custom repairs to the electric interface to make it compatible with the DC network and make it stable.
Okay, the methodology of the article is the application of fax technology in the smart grid. The first part means to fax is a flexible AC transmission system. It says that which combines the power electronic device with the most modern control technology to realize a transmission system parameters of the original communication. Okay, in this case, during the process, it requires the smart grid should improve the transmission capacity of the lines and solve the related problems such as a system oscillation, voltage, instability of the other issues. In the first part, they create a static barrel compensator HBC and thyristor controller series compensator TCSC. but they create a new part for develop this application is a static synchronous compensator STITCOM and Unified Power Flow Controller UPFC.
So the key direction of development of the FACTS in the next 5 years, what are the direction that will take this technology? The first is the application of the 7500 kilovolts and to 1000 kilovolt controllable series compensation technologies. So it's more like a period of experimentation with this technology. Now, to the second is the application of the controllable high technologies of these 8 voltages. To the third, the key technology of the static synchronous series compensators, SSSC, and the UPFC. Those were the ones that Ana Lanchero mentioned. For the research of the facts FACTS, which based on the wide area measurement system, the WAMS. So make a research with the results provided by the experimentation and to make improvements and propose more solutions to the problems that end up occurring.
Okay, in the second table is an example of this application. It says that main technical parameters of the BSC and HVDC converter is an example of 2 countries, and the project of the acceptance system still needs large research. Flexible HVDC technology includes voltage source inverter. It says that voltage source converter VSC and electronic insulated gate bipolar transistor. In this case, is the transistor of IGBT. A flexible HVDC technology developed of the 1990 with voltage source inverter, voltage source converter, it's a that VSC, and can shoot of the power electronic device. Insulated gate bipolar transistor, it's a that the transistor IGBT.
So the main technical parameters of the power quality technology. This technology has some parameters, the frequency, test error, or the error that can be produced in the frequency, some offset, if you may call it, the voltage deviation, or yeah, the deviation that has the voltage, the phase angle error, the difference between the phase and the phase angle, the power deviation, and the power consumption. All of these parameters are pretty low. This is a pretty stable technology, but the power consumption is also low, so it's pretty optimal for a big system, for a big area.
Okay, and the last one table, it's an example for the performance of non-Hue smart grid. This picture can be seen that the application of the advanced power electronic technology in a smart grid can improve the safety, stability, efficiency, and quality. It also can be observed that all the parameters of the performance of a smart grid enhance it to 80%.
So, in conclusion, the construction of the smart grid is still in its infancy. It has a lot of space to grow, and it will take still some years. But the result shows that the application of advanced power electronics in a smart grid will make the safety factor, stability factor, efficiency factor, and quality factor increased over 20%, 19%, 50%, and 40% respectively, which give us a little conclusion that the use of power electronics in a smart grid makes the systems, the grid a lot more efficient, gives more quality to the energy, and sorry, it makes it more stable, and it makes it more safe nonetheless. So this was our presentation about the study on the application of advanced power electronics in a smart grid. I hope you liked it and it clarified something to you.